Phosphorus is a key ingredient in fertiliser and vital for food productions around the world. And yet, according to some experts, mineable reserves of it may be completely depleted in a few hundred years. At the same time, excess phosphorus entering our rivers from sewage works and fertiliser runoff is causing huge environmental damage. I'm Amandeep Bangu in England to see how recycling an unlikely byproduct could reduce pollution and pave the way for a greener way to grow our crops. Alice Holden is an organic farmer who works at a growing communities farm in East London and is a passionate advocate of the sustainable use of phosphorus. Hi Alice, where do you want me to help out?
Okay, I'll just get a box. If you go for any of the reddest tomatoes.
The reddest ones, okay.
Yeah. For all plants, whether they're conventionally grown or organically grown, they need certain trace elements. Without phosphorus, the plants won't be healthy and they won't produce good crops.
Phosphorus is vital to plant growth and is found in every living plant cell. It's absorbed through root hairs and is involved in several key plant functions.
In terms of feeding large-scale populations, it's completely critical. How you get that phosphorus is done in lots of different ways. Our main source of phosphorus is from phosphorus mining, predominantly in North Africa. And that's a finite reserve of phosphorus. We're using up these mineral reserves that have taken millions of years to develop, but we're using them up very rapidly.
And if phosphorus levels do deplete, how big an impact will that have on agriculture and food production across the world?
Well, our yields would drop hugely. It would dramatically impact on all crop yields.
It's estimated that with our rising population and changing diets, there'll be a 70% increase in global food demand by 2050. On organic farms such as this one, phosphorus is recovered by composting animal manures and plant waste.
All of this plant waste has phosphorus within it, which once composted will be in the compost that we make, and then that in turn will go on to feed and grow new crops.
This is pretty stinky, smelly stuff. It's like a perfect summer's day and the perfect weather and conditions for this to really stew up, so yeah.
It's really grim.
So this is one solution to combating depletion of phosphorus. You're actually recycling the phosphorus that's already in the system, already in the environment, already in food sources.
Yeah.
And you'd welcome different types of solutions.
As long as the whole picture is looked at in terms of sustainability, then absolutely. I think there's lots of parts of the system where we lose phosphorus, so there's lots of parts of the system that could be addressed and tapped into.
As well as the huge concerns about our mineable reserves of phosphorus running out, there are massive environmental problems stemming from the way it's currently used in agriculture, where excess soluble fertiliser flows into our rivers and waterways, resulting in what's known as eutrophication.
Well, phosphate's a fertiliser, so it causes the increased growth of plants and algae. So when you get an algal bloom, you get massive amount of photosynthesis occurring, which causes fish and the wildlife in the rivers to be in distress, and it can actually kill them. Most of our rivers are failing for phosphate. If it's not reduced now, we'll get more fish kills as a result. Our lakes will become deoxygenated. There'll be no life left in them.
And this phosphate fertiliser runoff occurs in these lower reaches of rivers across the world?
Oh yeah, everywhere will be affected by fertilisers.
So I'm about to meet Shaz. She works with the Environment Agency as well, and she's checking the local water levels for phosphate. Hey Shaz,
Hi.
Hey!
Okay, so what we're doing is taking a water sample off the river.
Just lowering it down?
And try and get a full bucket.
And how often do you conduct these tests?
Well, we do it about once a month.
It's looking really green down there. Is that a result of phosphate levels high?
Well, that's an indicator.
And this level that you're testing today will prove whether that's down to the phosphate?
Exactly, yes.
What do you reckon? Do you think that's enough?
I think so. Let's bring it up.
Let's heave it up then. Right, so that's ready to be sent off to the lab for testing. And looking at it, it looks pretty clean and clear. But lurking inside is something that's killing off wildlife in this river and rivers across the world, having a huge environmental impact. On the other side of London is a sewage plant that's trying to deal with both the shortage of phosphorus and the environmental damage that it currently causes. Based on technology developed in Canada, this is the first plant in Europe to create a brand new fertiliser out of raw sewage. It's called Crystal Green.
I have a hard hat and high-vis jacket for you.
Fantastic.
And some gloves as well if you want to touch some of the sludge cake.
The sludge cake?
Sludge cake is what we call it.
Right.
I've
heard of other cakes in the past. I've never heard of a sludge cake.
No, this isn't the nicest one now.
This is basically treated waste, is that what it is?
Yeah, so this has been digested, so there's no pathogens in this. In this sludge cake, there's a lot of phosphorus and nitrogen, which obviously you know are good for plants.
It doesn't actually smell at all.
No.
And it's just, you just want to kind of play with it. It's really cool in this hot summer.
It is, isn't it?
We've just been to a river and we've seen the damage that can happen from eutrophication, from the excess phosphorus in fertilisers like this.
Exactly.
And what exactly is it that you're trying to do to tackle that problem?
We're making a low solubility, high phosphorus fertiliser. So it means that we won't have the same problems with leaching and eutrophication that we currently have by applying this kind of fertiliser to land. This is where we recover our phosphorus from, all in this tank.
Wow.
Yeah. So we can go up to the top and see, we can look down inside the
Sure.
tank,
Okay.
see what's happening.
It's like a giant corkscrew.
You can see inside here.
Wow, so what's happening in this vat?
This is the liquid that was taken out of the sludge cake that we saw before. So in this liquid, there's lots of phosphate and lots of ammonium. So we add a little bit of magnesium and we adjust the pH a little to make struvite fertiliser form. So struvite is magnesium, ammonium and phosphate mixed together, which make a really good fertiliser. Yes, this is the struvite fertiliser, and Sharif here has been doing our research on the struvite fertiliser for us.
Hi, Sharif.
Hi.
Can I have a look?
Oh, yeah, sure.
Wow. And what's the benefit of this, Sharif? You've been researching this.
Our research shows that crystal green type fertilizers tend to dissolve very slowly in the absence of roots. So when there is no roots nearby and there is water present, it dissolves very slowly compared to, say, traditional fertilizers, which breaks down and dissolves very, very quickly. Now, the obvious advantage of this from an environmental point of view is that you tend to have a much less amount of leaching into the waterways, but also some of our preliminary results show that in the presence of roots, crystal green tends to be plant activated in that roots tend to exude acids, and in the presence of acids, crystal green dissolves. So effectively, it's plant activated in a way.
With phosphorus depleting, with us polluting our river systems at the moment,
Yeah.
this could be the future.
Yeah, the aim is to close the phosphorus loop though, which we can achieve.